Today we have Caverly. He's a machine learning researcher at RiskLab Toronto and investment data scientist with OMERS Capital Markets. His work focuses on applied machine learning in portfolio construction and risk management, with a particular interest in AI systems and natural language. So I'll let him kind of expand on his work. Thanks.
Awesome. Thanks, CMLS, for hosting. My name is Kyle Caverly. I'm a machine learning researcher at RiskLab Toronto. And what I'm going to be walking through today, I guess, is natural language processing, specifically for automated portfolio construction. Today, I'll be talking through it in an ESG context. However, it works for really any sort of context within the news. And really, what does this mean? So for us today, I'm going to be touching on two topics. The first one is why natural language is important for finance. And then once I get through that, I'll be walking through an end-to-end example in which I walk from both the data collection piece to the modeling piece to the signal generation and portfolio construction piece on a real life data set, working through some research that we've done at RiskLab. So thanks for the original bio. I'm just going to touch on it real quick. My name is Kyle Caverly. I'm a CFA charter holder and a machine learning researcher at RiskLab. RiskLab is a research group done at the University of Toronto by the Department of Mathematical Finance and Louis Seiko. Professionally, I'm an investment data scientist at OMERS Capital Markets. In my free time, I do some grad work at Georgia Tech in computer science and analytics. So to really ground the discussion today, when I think of why natural language is important for finance, I always think back to where we currently are. And when I reflect on where we are, there's really three key areas that pop out for me. The first one being that the scale and the speed of information is growing at an exponential rate. And I'm sure I won't be the first one to kind of walk you guys through the growing information gap between the amount of information being published and what we can actually consume in our decision-making day-to-day across industry. But of course, it's incredibly large and grows continuously. And at the same time, the investment universe is larger than ever, right? With the increased sophistication in markets, we have greater access to new markets and asset classes than we really did previously. And yet, despite the above, yield and alpha through traditional means are scarce. And so what does this mean for you as an institutional manager? It really means that you often find yourself, I guess, having to keep track of both a growing number of interest areas focused on what's existing in the portfolio, while at the same time keeping your eye on the universe around you to try and optimize or identify new areas where you can kind of push your portfolio to generate additional alpha or optimize for your return mandate. And in this sort of environment, I think there's only two primary routes we scale as an industry. The first one, of course, is that we can hire more. So we do more of what we currently do. And the second one is to build better tools. So do what we do, but more efficiently. And of course, as a programmer, I fall into the second category of build better tools. And today I'll be walking through how natural language, I think, solves a key gap for the industry. Specifically, I think natural language is key to closing the gap for the organization, looking to take on a more quantamental approach to investment. And now the great thing is that these more esoteric workflows from the past in research are more accessible and applicable than ever for everyday organizations. And this is really due to two, I guess, primary areas. The first one being that research in natural language surrounding the advent of transformers and contextual embeddings have really pushed what we can do with machines as far as we're now able to actually surpass human level accuracy for certain key natural language understanding tasks like classification. And then coupled with this, there's been massive infrastructure developments through the use of open source tooling, which has now really made machine learning lifecycle feasible for average everyday organizations. And one data set I think that really encapsulates what we can do with natural language is, of course, the news. And the news is what I'll be focusing on for the remainder of my talk. what news does is it offers us a way to really introduce non-traditional information into the portfolio. And if I think about the role of the news in the investment process today, it holds a very critical role. So regardless of your investment focus, you're consistently paying attention to developing narratives at the companies and industries you're focused on. Regardless of whether you're an equity manager that manages a portfolio with a quality focus, or a merger arbitrage trader, you're using the information consistently from the news to kind of inform and shape the narrative that you craft around your investment decisions. And while I'll argue that traditional data sets will always provide the foundational backbone for investment decision making, news events and the narrative surrounding these events do drive price action, and they do drive investment action by portfolio managers. And if I think about news, there's really three characteristics that makes news valuable. And the first one, of course, is speed. So news information is shared continuously. It's really the only way to stay afloat of what is currently going on in the organizations we're interested in. And while you may receive quarterly or irregular kind of company announcements throughout the year, these are often few and far between for many organizations. And news may be the only way that you can kind of keep track of what's going on inside your portfolio. The next attribute is, of course, breadth. So many fundamental data sets will focus in on one particular area of interest, whereas news has the remarkable ability to kind of encapsulate the entire environment surrounding the investment process and really what makes a company tick and succeed. And part of this is that the quantity of this information is tremendous. Say, for example, if I wanted to pay attention to which healthcare providers are most focused on innovation, or which food companies are frequently discussing clean eating and the shift towards meatless products, I don't know of a traditional data set that can kind of allow us to quantitatively engage with this information. And this is a huge aspect and value that news data brings to the org. The third one, of course, is the materiality. So like we can take one look at something like the GameStop saga or price action on Tesla stock whenever Elon tweets, to see that news events and public's perception of news events do drive price action, and they are very material. What we end up seeing is that news events are often the first mention of a concerning shift in a company, successful product launches, or something like an FDA announcement. And these are market-moving events, which we form our opinions on and really shape our view of the investment universe. And so a great way to kind of encapsulate this is to walk through an example. So I'll touch on Johnson & Johnson. Of course, Johnson & Johnson is an incredibly well-known company. It's a household name, a blue chip stock, set and forget it asset for many, and it's got a great fundamental profile. However, there are negative reputational risks to Johnson & Johnson surrounding the opioid epidemic in the United States. And I've put up a few headlines here. The first two, of course, are about Johnson & Johnson, the third one being Purdue. But this is a very material impact for Johnson & Johnson. And what I found really interesting is that these sort of risks kind of began to emerge state by state in the United States as each state announced its own lawsuits. But it built to a point where there are now material impacts to Johnson & Johnson's bottom line. And at the same time, we see Purdue, who is a separate company to Johnson & Johnson, of course, but often listed in the same lawsuits. And the size of the claims for Purdue has gotten so large that Purdue's had to announce bankruptcy as a result of these claims. So these are incredibly material events for the portfolio. And if you're looking at these assets from a fundamental perspective, I don't know if there's a way that you can kind of monitor and engage with this information without spending time, frankly, going through the news yourself. And so how do we kind of integrate this non-structured news information into portfolio construction? There's really three pieces I'll talk to. The first one is, of course, the natural language piece. So how do we train a bot to identify problematic news events from machine readable news? The second piece is signal generation piece. So how do we roll up or aggregate these individual news articles to a company level aggregate metric over time? And then finally, the third piece is portfolio optimization. How do we actually integrate this signal into a portfolio optimization process that makes sense? And what I'll talk to is this process that we work through at RiskLab is generally focused on a participatory approach. What I mean by that is many organizations will kind of blacklist certain companies or industries from investment. And ultimately what we were looking to do is build a process that incorporates this information without completely excluding large portions of the investment universe. So let's tackle the NLP piece. How do we actually train an ESG classifier to identify problematic news events from text data? The first piece is every project, of course, needs a data source. So for our use case, what we did is we leveraged the New York Times Developer API to generate an archive of news articles from 1990 to 2018. These were news articles specifically focused in on companies listed in the S&P 500. And so once we've got our data set, the second piece is, of course, modeling. Now, unfortunately, no publicly available labeled data is available inside the ESG space. And this is a big problem with most deep learning models. And so to combat that, what we did is we actually trained BERT on noisy author labeled data from the New York Times archive. What I mean by this is for each individual article in the New York Times, there are author labels, right? So the author will write the article and he'll say, this is about pollution and waste, or this is about corporate governance, etc. But unfortunately, they're not consistent over the whole corpus. So what we did is we actually used those existing author labels as labeled pairs and trained BERT, a transformer method, on this data set to generate an ESG classifier. And while the data is incredibly noisy, BERT does remarkably well at identifying and classifying these ESG topics of interest at scale. And what this ends up doing is it leaves us with a vector of ESG scores, right? So technically, this is a sigmoid vector where we have a value between 0 and 1 for relevancy between an article and a topic of interest, stuff like product liability, anti-competitive practices, pollution and waste, etc. And we can use this downstream to actually drive signal creation and portfolio optimization. The one thing I'll mention here is specifically the use of BERT. So if you're on top of NLP news in finance, what you find is that not a lot of people will use transformers in machine learning research in finance. I think there's a few reasons for this, but why we chose to go down the BERT route specifically, I think BERT is, of course, more difficult. It's a large model, and it does have operational considerations. But if we're looking at this as solving a true problem between integrating humans and machines with a system focus, with any sort of human in the loop sort of solution, I believe BERT is worth the effort because it provides for an incredible feedback loop in which between humans and machines, which will ultimately provide the most value in organizations looking to tackle natural language from an ML lifecycle or an ML product sort of focus. So once we've got our article scores, where do we go from here? And the second piece is, of course, signal generation. How do we generate company level daily scores, which are informative and balanced? Now, this is the hardest part of working with news data and alternative data generally, and most alternative data sets that aren't delivered from a consistent perspective. The first challenge is inconsistency. So news data is incredibly volatile as to who receives coverage, how often it occurs, and this makes daily metrics incredibly challenging to manage on a short-term basis. This is primarily the reason why most research you'll read on news-based trading has incredibly high turnover for the portfolio, that is. And so what we're looking to do is we're trying to keep a balance, right? We'd like to build a portfolio that takes advantage of the dynamic nature of news data without these incredibly high turnover windows where we have simply like a 7-day average holding period in the portfolio. These sort of strategies aren't really going to work for a lot of institutional managers. And so for us, what that ended up doing is we used a 90-day look-back window to aggregate scores over. So as such, what we did is we went from an article level score to a general count of the ESG events over the previous 90 days and use this as the base of our signal. The second challenge with signal generation is bias. So when aggregated at a daily level, news data is aggressively skewed. A small number of companies receive an incredible amount of news relative to their peers. And so for us, what we did to combat this is we just clipped the values of the 95th percentile. While this isn't a perfect metric by any measure, this brings the long tail companies closer to their peers without removing or taking away too much of the information inherent in the distribution skew. And very related is the third challenge, of course, which is non-normalcy. So in quantitative finance, we're incredibly lucky to work often with normal data. Most signal factor data is almost always brought back on a z-score basis to normalize the data and compare between companies. And for news data, it's very difficult, if not almost impossible to work with. For us, what we chose to do is we use a min-max scaler instead, which actually generates a continuous score between 0 and 1, which are directly interpretable while retaining some of the information present in the skew again. And it's really this 0 to 1 score for each individual company that we pass upstream into a portfolio optimization approach. So how do we actually integrate this data into a portfolio optimization process? I'll be talking through Black Litterman as an option for machine learning generally. And what Black Litterman is an optimization approach in which there's two primary inputs. These are covariance matrix of returns along with the market cap values. And what Black Litterman actually does is it infers a return target, assuming that the market is somewhat efficient. And that generates an expected vector of future returns. What we can then do then is layer on our views vector as essentially a return transformed, as essentially a vector of our signal transformed into the return space. And what this allows us to do is essentially tilt the portfolio away from ESG sensitive topics while still participating in those individual assets that are somewhat problematic. And so what does that really result in? So this results in some really interesting industry tilts. So I have two plots on the screen now. What they represent is they represent the industry tilt between a vanilla Black Litterman approach and an ESG Black Litterman approach. What I mean here is essentially these are the industry tilts that happen when the bot reads the news versus doesn't read the news. And the lighter the color, the more overweight the ESG bot is, and the darker the color, the less overweight the ESG bot is. And we do find some really interesting action, specifically surrounding financial sector and the information sector. So what's really interesting is that when the financial sector is going through market volatility, like it was in 2014, the ESG bot actually starts to underweight the finance and insurance industry. And I believe it's due to the fact that we introduced an idea of corporate governance into the model. And this underweight becomes more prominent as the market moves sideways throughout 2015 in the aftermath of the flash crash. The second piece that I found really interesting is that the model underweights the information sector in the aftermath of the Donald Trump election in late 2016. And this is due to the fact that the model incorporates news stories around data privacy and security. And so in the aftermath of the election and throughout the Cambridge Analytica scandal, what we see is that the ESG bot will actually continuously underweight the information sector to kind of stay away from this high profile issue. And I know immediately looking at it saying you're underweighting tech, people are going to say, how on earth did you make money? The truth is what's really interesting about it is when we monitor the returns between both the vanilla Black Litterman and the ESG Black Litterman approach, the ESG Black Litterman approach remains competitive and beats the vanilla Black Litterman approach, even when we're underweighting key return sectors like technology. And so at the end of it all, so what? Why does this matter? What I believe is that non-traditional data like news really allows us to quantitatively measure and engage the qualitative narratives and concepts surrounding our investment universe in a way that we really can't right now. And as we take the next step as an industry and kind of focus on building machines which truly integrate between humans and machines, we're going to need a consistent, effective, and trusted way to quantify these sort of non-quantifiable aspects of our current environment in a way that will allow us to move beyond machines that simply inform our decisions to machines that truly kind of accelerate and complement our understanding of the finance universe, investment universe. And so that's all I've got for today. Thank you very much for tuning in.
Great presentation. I learned a lot, very informative, very insightful. So I guess in terms of your, because you talked about kind of scalability and performance issues using these transformer models, which are less scalable than maybe kind of simpler. If you just had word embeddings, you're just taking like TF-IDF word embeddings. So how do you scale them? And then where's kind of like the trade-off in terms of maybe how much data can you like how responsive is your algorithm? Like what's the time scale that you can apply this kind of like transformer-based inference on? Yeah, that's kind of like scalable.
Sure. Yeah, I think for most organizations, if you're working on a batch basis in which you're kind of keeping you're updating your data overnight, even as complicated as transformers are, modern infrastructure kind of allows us to manage that without a problem. You can run daily inference on news flow of tens of thousands to hundreds of thousands of news articles using BERT in a few minutes. And I don't really think anymore it's too much of a challenge from that perspective. I think BERT doesn't get picked up in industry as much due to two things. The first one is interpretability, right? So in finance, we need to know exactly why certain things are happening. And with BERT, that's still a challenge at a global level.
Right. So I guess
it's a drawback, but
there are some techniques along, like one kind of naive approach is just kind of look at the attention weights and see what is being attended over. So you would say, okay, these are the features that are predicting this output, that kind of thing, or like are most correlated with the current output. And there's kind of other kind of methods, but you're right. There's still difficulty kind of overall being able to with some certainty say this is not kind of like these attention weights are actually correlated. They're not just kind of anomalous. Yeah, there's still kind of a lot of there.
I think. Sorry, the one thing is that I think it's pretty easy to interpret BERT at a local level, right? But it's pretty hard for me to hand over a BERT model to a portfolio manager and say, hey, look at these 100 sentences. What you find with more traditional NLP models is that we have importance values for individual words, right? So we can say that, okay, bankruptcy is negative, right? But in a BERT, like using contextual models, that becomes more difficult because if your bankruptcy ends relatively positively, you settle good, that may not be as negative as we think. So it's a bit of a balance, but it's hard to manage globally.
And so how do you calibrate kind of like the confidence of the model? Like you find that you can actually, like, let's say there's certain criterion, like Kelly criterion, which kind of like gets certain confidence about certain thing. And then so you'll weight your investment based on your confidence. Is there kind of an equivalent for the kind of these kind of machine learning models, assuming maybe that they're well calibrated, maybe they're not, but like, can you actually rely on the model confidence as well in order to kind of to kind of give some reduce kind of uncertainty maybe about or to kind of that model confidence actually the amount that you invest or the activity is kind of proportional to that? Like how does that work?
Yeah, absolutely. So I think the one thing that's really difficult is with a lot of news data specifically or machine learning models in which you're not running on daily aggregate metrics to begin with, right? Because there's two elements of confidence here, right? There's how confident am I that an article is about like corporate governance or product liability, et cetera. But then there's a second area, which is like, if I generate an aggregate daily metric, how confident am I in that aggregate daily metric? And so BERT makes it pretty easy for us to, like, you can simply just bin the accuracy levels at different kind of sigmoid thresholds to identify how well calibrated the article piece is. But aggregating these metrics into a kind of useful daily metric is really challenging. And I don't think, I haven't seen a good way in which we can kind of infer that confidence at a higher level without kind of engaging it directly on a human basis. And so to that, I think that only reinforces the fact that for the most part, I see these as you do still have human in the loop to a certain extent, right? We're not going to hand over keys completely to a systematic process, but it allows for really accelerated workflow with kind of your own digital NLP assistant to a certain extent.
Yeah, that's very exciting. It's kind of like maybe there's the sliding scale between full automation and kind of human assistance, like where it's kind of assisting humans. So you're kind of making the human more scalable. And so there's kind of like, do you find where does in what situations is human intervention necessary? Like where is, like, in terms of, let's say, how is the model affected by kind of data drift in terms of like news articles and maybe how like sentiment kind of changes? Like, so like how does that aspect of it, I guess?
Yeah, I think that data drift is a really interesting point because like the most talked about, I guess, method in NLP is, of course, this like Laughlin-McDonald dictionary from 2011 that everybody's kind of used. It, of course, has no idea what COVID is, right? And if you look at a lot of like traditional ways of managing NLP, like the funny thing is that the term surge is generally seen as an incredibly positive term in financial research. So nowadays in 2021, the term surge is not a positive metric for financial research. And so you do, like, if you're thinking about a transformer-based approach with a real systems focus, what you can find is the ability to actually engage one-on-one and kind of provide direct feedback to the model allows you to continuously update and manage your models for data drift to a certain extent. An event like COVID, for example.
Right. Yeah, because it seems like there's certain kind of outlier events that maybe aren't predictive in the historical data. You can't really look at historical data and say that like COVID, the kind of like how it impacted like the economy, that kind of thing. Yeah, it's very hard to kind of to account for outliers in kind of like
absolutely
models, right? So I guess in terms of like maybe from implementation kind of side and frameworks for kind of testing and yeah, just kind of your deployment of the models, like how do you kind of like what does that aspect look like?
Yeah, for our backtesting method, we found that generally we had to kind of work on our own, like just put together a simple backtesting method. From even like I don't know if we want to get into something like model management, but like throughout the life cycle of this, there are some tools and techniques to kind of help along the way. Like even when it comes to training, like there are methods that you can use even on noisy data to kind of accelerate the labeling process and make it a bit easier for you to go from a noisy data set to a labeled data set, which is better suited for something like BERT. But a lot of that, like, you use stuff like Snorkel, which is a publicly available tool to help a little bit. But a lot of this stuff is still fairly manual, right, with regards to how we clean our data and get it to a point in which it is valuable for us. And that follows through all the way from like the natural language piece and data collection all the way through to backtesting. It's kind of surprising how poorly constructed a lot of public tools are for backtesting, and portfolio optimization to the same approach. So throughout the process, there are definitely areas where you kind of have to get manually engaged and build your own.
That's fascinating. So I guess what about in terms of the kind of text sources? So you mentioned news. There's maybe other sources like 10K or quarterly reports, kind of different kind of like other kind of information sources that are also very kind of informative and
yeah, absolutely.
So like, do you think about that? Is there regularities in this that you can kind of exploit or?
Yeah, I mean, a lot of the work surrounding like earnings or 10K, specifically surrounding like the management discussion analysis piece, is on Tone, which is a really interesting work. We never got into it in our project. It comes up elsewhere. I think the general extension that you see to something like this news framework is to incorporate additional sources like Twitter, for example, or people are all over trying to get Reddit data on board since the GameStop sort of fiasco. I see extensions in that as opposed to directly lining up the same methodology against a 10K. Management MD&A is going to be a lot easier due to the regularity in the data.
Right. In terms of, let's say, like entities in the data, entity detection, sentiment detection, is that something that are those additional features that might be like, let's say if it's a news article, you want to extract the entities, like how accurately can you kind of do that?
I mean, with transformers nowadays, both entity and sentiment is pretty good. The biggest problem is, of course, labeled data. In financial data, we don't have any sort of like, there's a question in the chat about greenwashing. There's no polarity right now in our model, and that is a drawback. In real life systems, what you'd expect is you have a topic model, which identifies if the area is of interest at all, right? So if the news article is about like the Toronto Maple Leafs, we don't want it hitting the model in any capacity. Once I know the article is generally about something like product liability or climate change, you then need a polarity model to kind of infer if it's positive or negative. We took a different approach with this, but I think over time, being able to create a labeled data set, which really provides you those granular metrics for sentiment, are going to provide the most value in the space.
Right, and it's just kind of the difficulty of being able to kind of generate that those labels, I guess.
Yeah, labeled data doesn't exist for any of this stuff right now, right? So if you want a data set on if a news article on climate change is positive or negative, that doesn't exist without like getting a few analysts hands on keyboard or grad assistant.
For sure. I guess in terms of like going back to that greenwashing idea, so how do you kind of account for companies, when they introduce bias or try to bias the reports to look good on these kind of ESG metrics? How do you debias it or denoise it, or maybe account for like maybe use metadata kind of like, how do you address that?
Yeah, I think generally like we're not looking at that granular of a level as to if an article is individually like too positive. What you do find though is that companies do push a lot of news that supports their point to a certain extent. But I think at a certain level, like once you manage for scale, the news does manage that away itself. Right? If you Nestle, they put out a big thing about how they're going, like they're helping Manchester City go vegan, for example. Like if the news doesn't care about that, it doesn't matter if Nestle is greenwashing, right? Because if that news story doesn't pick up and get momentum and mention beyond just the Nestle corporate announcement, that doesn't pick up at all, or just a very minor event, right? The way the model is focused, especially when you're looking at count information, is it's looking at high-profile events to a certain extent, right? So something like SolarWinds and the hack on SolarWinds, you're going to have huge red flags in corporate governance and data privacy and security, et cetera. But if you have a small time data issue somewhere, like you get a 0-day hack in Microsoft, like that's not going to generate enough news base to really affect the stock price or the market news generally. So that's the approach.
And there's a lot of complexity in terms of like, so let's say, how do you, like, let's say if there's some negative information about like a certain company, like there's a lot of activity around, there might be shorting of the stock, there might be kind of like different, so how do you then translate that into kind of action? Like what is the model, like how does the human kind of interpret the output of the model, and like where's the, like how much human kind of expertise is necessary to make these really kind of performant?
Mm-hmm. Well, you're going to have the same sort of portfolio construction process that you have in the remainder of your portfolio. And so a lot of the human drives that process to a certain extent, right? Like introducing constraints on individual companies and the amount of risk that they have or the proportion of portfolio that can be focused on a company. And that's always going to exist regardless of your data source. And that's a way to certainly manage the risk of the ML model as well, because even if you do have anomalies in your metrics day to day, if they don't make an impact down the line due to broader controls in the portfolio construction process, it really won't matter that the metrics that far off for a specific one-off company.
Right. And so for like these different metrics, like let's say for ESG, like what are easier to predict than others, and like how can you infer what time scale they might have kind of an impact on? So for example, anti-competitive kind of news for the tech sector, there seems to be, there's more mention of regulation coming down, so there's this expectation that regulation will come, and there's kind of in terms of like anti-competitive kind of practices, but you don't know when necessarily, so you don't know how the timing of it, like the trade, like how that will be affected. So how do you kind of how do you account maybe that kind of information?
Yeah, in our scenario, we're not looking at that. Like, we're rolling the portfolio over on a monthly basis, and then reweighting at that point. Ultimately, like you would look to see if you're focused on transitory events, like momentary events in the company, or a longer term change, right? Like, you see it all the time, like with director changes, for example. A director change will come on, the stock market returns, maybe it moves a little bit, but realistically over the longer term, it doesn't matter at all. And so there are certain labeling methods. We didn't use them in ours. You can use something like the triple barrier method, for example, in which you kind of monitor your position on a walk forward basis to see if it hits a price target or a floor. And those sort of metrics can bring it back to identify what's the time length for these trades versus, and really nail what singular events and the news are actually relative to the portfolio.
That's very interesting. I guess in terms of like these kind of news sources, maybe this will be the last question. You've been kind of great for sharing this, but so in terms of like the news sources themselves, weighting how much you weight that particular, let's say if it was all from New York Times, certain writers are definitely more biased. Maybe they are. Is either like implicit kind of bias, or there's certain incentives that kind of bias them. So how do you kind of weight that particular source in terms of?
Yeah, I know a lot of like industry available machine readable news keeps their source base to be relatively succinct, which is good. You are kind of relying on that to a certain extent, right? There's a big difference in if you're generating a news corpus based on the New York Times versus scraping from the internet. Because the internet has a ton of stuff where you'll see companies kind of stuff the news to support their view. News sources generally are more balanced. I think authors definitely are going to have their own individual bias that push news data. But at scale, we hope to a certain extent that washes, right? And I think, it is a balance between how do we get enough data into which minor kind of discrepancies in news flow are no longer an overarching problem for the whole data set. But all the sources are available, right? So if you wanted to overweight, say, CNN versus CNBC or whatever your specific focus, a lot of machine readable news sources in industry will provide you with that flexibility if that's where you want to go.
Right. So you're kind of assuming in aggregate, these kind of biases will get canceled out or averaged out. I see. Informative talk, very knowledgeable on this topic. I've definitely learned a lot, and so is our audience. Thank you very much for your time, Kyle.
Awesome. Thanks, guys, for hosting. I appreciate it.